I share my screen. Okay. Thanks everyone to be here. And today I'm going to introduce Uniswap v4. And I think it should be quick because there isn't too much change about the AMM algorithm. Most of the change are on the architecture side, so it should be quick. And if you have any question, feel free to jump in, and maybe we can have a discussion at the end or Q&A at the end. All right, let's get started. And here's the link. I'll paste it in the meeting chat. First one is the AMM algorithm. In Uniswap v4, they use the same AMM algorithm as v3, the concentrated liquidity. So there isn't too much change, but you can have multiple pools for same pair. So everyone can create a pool for a pair. Pretty similar to Balancer, I think. And each pool can have different parameters such as tick spacing, fee ratio, and hooks. I'll explain hooks later. And tick spacing and fee ratio is the same idea in Uniswap v3. But in Uniswap v3, they have fixed choices for tick spacing and fee ratio. But in Uniswap v4, everything is flexible. You can choose whatever parameter you want. And this design brings another issue is that liquidities are fragmented across multiple pools, just like Balancer. So it would be a challenge for the swap router, and there isn't an open source swap router for Uniswap v4. So let's see how they implement it. So as I say, there's a new idea that is hooks, just like this picture. In each pool, they have different colors. Yellow one, the pink one. This is the hook of a pool. So each pool can have at most one hook, and the hook is a contract that can be executed at certain stages, such as before swap, or after swap, or before modified position, or after modified position. Modified position is the interface to add liquidity or remove liquidity. And they also have some other stages such as before, after initialize the pool, before, after donate to the pool. So hook is a contract that written by third party or written by Uniswap team. And you can create a pool and to be associated with the hook contract. And the hook contract will be automatically executed at certain stages. So hook will define which stages I want to be executed. Yeah, so you have to define which stage the hook contract will be executed, and the pool will call the hook contract automatically at these stages. And this is a simple example of swap hook. So some users start a swap in a pool, and the pool will check the before swap flag of the hook address. So if it is true, it will execute the hook contract by calling it, and it will run the logic in the hook contract, and it will return. And after that, the pool will execute the swap. And after the swap finished, it will check the after swap flag again. And if it's true, it will call the hook contract again. And after return, the swap ends. This is a example for swap hook. You can also write other hooks for like add liquidity, remove liquidity, or something others. And there are some use cases like limit order using the range order in Uniswap v3 and the time weighted AMM. And you can write customized Oracle in hooks. And you can write hooks to internalize the MEV profit. And you can auto compound LP fees back into the LP positions. And the hook can define the swap fees. So you can write a dynamic fee hook, and the fee can be based on volatility or some other inputs. But the hook is a contract. Remember, hook is contract. So all the logic in hook must be on chain. So there, you cannot write off-chain logic in hooks because it's a on-chain contract. All right, that's all about hooks, and maybe I'll explain some example hooks later, like the limit order or something like that. And let's continue. This one is about the architecture of smart contract. So they use a singleton contract. That means all pools are sharing one single contract, and all the tokens are stored in it. This brings some benefits. When you create a new pool, you don't need to deploy a new contract like in Uniswap v3 or v2. And it's easier for integration because there is only one contract address. And tokens don't need to be transferred in a multi-hub swap. I'll explain this later. And the next one is Flash. They call it Flash accounting. Flash accounting is like a Flash loan. That the process is like user acquire a lock first, and then they do whatever they want, like swap or add, remove liquidity, or they can borrow token from the pools. And after all the operations finished, and I'm sorry, in these operations, the contract will record the delta value of the user. So maybe you borrow some tokens, they will record how much you borrowed, or you swapped, they will record how much is the token in and how much is the token out. They will record all these delta values in the lock. The lock is a transient storage, so it will not be saved after the transaction is done. And after all your operations are done or finished, the user need to pay or receive the tokens they get, pay the tokens they own or receive the tokens they get, because it's all being recorded in the transient storage. And that means you can save some token transfers, like this example. In Uniswap v3, this is a multi-hub swap, like ETH to USDC and then USDC to DAI. And the second swap is also multi-hub swap, ETH to USDT and USDT to DAI. In Uniswap v3, you have to swap ETH to USDC first, and you have to send your ETH token to the first pool, and the first pool will send out USDC to your contract or send to another pool, and then the DAI send the DAI tokens to you. So the USDC token is being transferred, and same as the first swap, the USDT token is being transferred through different pools or routers or your contract. But in Uniswap v4, they only have one contract. That is what I said, a singleton contract. And all the tokens are stored in it. So the same swap as this example, they have two multi-hub swap, and the USDC is only USDT and USDC are only used as intermediate tokens. They don't need to be transferred at all. So the USDC is still in this contract. They don't need to be transferred during this swap. So the input token is ETH and output token is DAI. So only the user only need to send ETH to the contract and get the DAI tokens from it. So there are only two swap in Uniswap v4, but there are maybe 1, 2, 3, 4, 5, 6, like 6 token transfer in Uniswap v3, and it can save some gases. The last one, like I said, is very quick because there isn't too much change. ERC 1155. ERC 1155 is like a combination of NFT token and the ERC20 token. And the user can save their token in the Uniswap contract, v4 contract, by minting a ERC 1155 token. They have a interface that you can call like mint. As this example shows, you want to swap your ETH to DAI, and you have to fetch your DAI tokens at the end of the transaction. But if you don't need to like spend your DAI tokens, and maybe you want to use DAI tokens for further swaps, you can just save your DAI tokens in the v4 contract. So you only need to send your ETH tokens to the contract, and the output token you can save in it by minting a ERC 1155 token. The benefits are, if you have some further swaps that use DAI as the input token, you don't have to transfer DAI token from your wallet to the contract again. So it can further save some token transferred across multiple blocks or multiple transactions. So the benefits is to reduce token transfer. And maybe at someday you want to get your DAI tokens out, you can just burn this ERC 1155 token and you can get your tokens out. This is useful for frequent swappers or MEV boats. They do a lot of swap, so they can save a lot of token transferred between their contract and the Uniswap v4 contract. Or like liquidity providers that frequently add or removing liquidity, so they can save their tokens in the v4 contract. They don't need to be transferred. So that's all. That's all about the changes of Uniswap v4. It's not too complicated, I think. Yeah. And maybe let's illustrate an example of hooks. Let's say a simple one is this limit order. So they have an example of hook of limit order, and through this hook you can just add a range order. So the limit order is a range order, and there's a single tick range order. So you can add liquidity through their limit order hook. They'll add liquidity through the hook, and it's a single tick hook. And when adding the liquidity, this liquidity should be out of the range because the limit order, you cannot be swapped right now. And after your range order is being swapped, this hook will automatically remove your liquidity. So that's like your order is being filled. So it's very simple. Just use the after swap hook. All right. Maybe I'll continue. There are some questions. First one, I don't know. Maybe you guys have more ideas. And The second one, yes, maybe we can, if we are using Uniswap v4, maybe we can utilize the hooks for maybe hot tap, like someone swap on our exchange and there's a price deviation, the hot tap maybe can arbitrage between the spot and the perp. But there's a problem that all the logic must be on-chain. So hot tap must be must be able to execute the arbitrage on-chain, fully on-chain. And the difference between Lugia and the V4 is that Uniswap V4 has the same AMM algorithm as V3, but in Lugia we don't have a constant like AMM algorithm, so everyone can define their own AMM algorithm. Is there a limitation on what LP can do in the before swap hook? Front run the trade and swap first. Yeah, they can front run the trade and swap first, but it should be fully on chain. So all the logic should be on chain. You cannot write like off chain program. In before swap, that LP has access to the upcoming trade size and direction. Yeah, I think yes. So that's all the questions. And if you have any other questions, feel free to jump in.
Yeah, I have a question about limit order. If we use a V4's hook, do we still can we just implement our limit order with V4, or do we still need a bot to do it?
We don't need a bot, but it's very limited because they use the range order. And I think we already discussed about the implementation of using a range order or something else, but we didn't choose the range order because it's hard to implement like stop loss or something else, some advanced limit orders. But the benefit is that we don't need a bot. We don't need a keeper. It's being automatically filled and executed in the hook.
Okay, thank you.
And by the way, we cannot just use Uniswap v4 right now because we already use Uniswap v3, and migrate from v3 to v4 is quite complicated. Yeah. Any other questions? Maybe you can, if you're interested, maybe you can dive into the code. It's not too hard because most of code are similar to v3, and maybe you can have more ideas about new ideas about implement a hook. Yeah, I think the most creative part are in the hooks. So there isn't too much hooks right now. Maybe we can see a lot in creative things further in the future. All right, I'll stop the recording.